For this problem, we have to figure out how many floors there are in the building. We know that there are 2 floors above her and 5 floors below her. To figure out the number of floors in the building, we can add the number of floors above her, plus the number of floors below her, plus the floor she is on. So this would be 2 plus 5 plus 1, which is equal to 8. So the answer to this problem is 8 floors. For this problem, we have to figure out how far in feet is the first student from the fourth student. We know that 4 students are lined up 6 feet apart in a straight line. So let's draw 4 students. I'm going to have this line represent a student. We know that they are 6 feet apart, so the distance between the first student and the second student is 6 feet. The distance between the second and third is also 6 feet, and the distance between the third and last is 6 feet. To figure out the distance from the first and the last student, we can add up all of these numbers. So we can do 6 plus 6 plus 6, and we get 18. So the answer to this problem is 18 feet. For this problem, we have to figure out how many cuts she made. We know that she has a ribbon that is 12 inches long. We also know that she cut the ribbon to pieces that are 4 inches in length. Let's start by drawing the ribbon. We can figure out how many pieces she cut the ribbon into by dividing the length of the ribbon, which is 12, by the length of each piece she cut into, which is 4. So 12 divided by 4 is equal to 3. So that means she cut the ribbon into 3 equal parts. In order to cut this ribbon into 3 equal parts, we need to cut it twice. So the answer to this problem is 2 cuts. For this problem, we have to figure out how many brownies have no crispy edges. We know that she cut the brownies into 3 rows with 4 brownies in each row. So let's draw the brownies. So let's draw 3 rows. Let's also draw 4 columns. If a brownie touches any of these edges, then it is crispy. So that means all of these brownies are crispy, which leaves us with only these 2 brownies. So the answer to this problem is 2 brownies. For this problem, we have to figure out how many girls are lining up for free pizzas. We know that 2 out of 3 students in front of Teresa are boys, so that means there's 1 girl in front of Teresa. We also know that 4 out of 9 students behind her are girls, so that means there are 4 girls behind Teresa. Adding Teresa herself, we get 6. So that means the answer to this problem is 6 girls. For this problem, we have to figure out how many fence posts are needed. We know that she needs to build a 20-foot long fence in her backyard. We also know that the distance between the center of each fence post is equal to 5 feet long. Let's start by drawing 2 fence posts. Two fence posts make up a 5-foot long fence, but we need a 20-foot long fence, so we have to add more fence posts. Three fence posts make up a 10-foot long fence, but we need more posts. Now we have a 15-foot long fence, so we have to add more posts. Adding our fifth post, we have a 20-foot long fence, so the answer to this problem is 5 fence posts. For this problem, we have to figure out how many crayons in total were given to the 6 children. We know that there are 6 children and each child is given 2 sets of crayons. We also know that each set of crayons has 4 different colors. Let's start by figuring out how many crayons each child gets. We know that each child gets 2 sets of crayons, and each set contains 4 different colors. So to figure out the number of crayons each child gets, we can do 2 times 4, which gives us 8. So that means each child gets 8 crayons, and since there are 6 children, to figure out how many crayons were given in total, we can do 6 times 8. And this gives us 48. So the answer to this problem is 48 crayons. For this problem, we have to figure out how many 10-inch squares she can cut out of the fabric. We know that the fabric is 36 inches long and 42 inches wide. To solve this problem, we have to figure out how many whole 10-inch squares she can make out of the length and the width. The length is 36 inches, so to figure out the number of whole 10-inch squares she can make, we have to divide 36 by 10. And we get 3 was the remainder of 6. We only care about the whole number of squares, so we only care about the 3, so we can ignore the remainder. So she can make 3 10-inch squares out of the length. Now let's figure out how many squares she can make out of the width. The width is 42 inches. And we divide 42 by 10 and we get 4 with a remainder of 2. So this means she can make 4 whole 10-inch squares out of the width. So to figure out the total number of squares she can make out of the fabric, we can do 3 times 4. So doing 3 times 4, we get 12. So the answer to this problem is 12 squares. For this problem, we have to figure out how many times the octopus can shake arms with itself without repeating. So let's start on the first arm. The first arm can shake with the 7 other arms, so we have 7 shakes. The second arm can shake with the 6 other arms, and not the first arm because the first and the second arm already shook, so we have to add 6 shakes. The third arm can shake with these 5 remaining arms, so we have 5 shakes. The fourth arm can shake with 4 other arms. The fifth arm can shake with 3 other arms. The sixth arm can shake with 2 other arms. And the seventh arm can shake with 1 other arm. Adding all of this up, we get 28. So the answer to this problem is 28 arms. For this problem, we have to find the location of the middle mark. We know that a meter stick is marked in 3 places with equal distance. We also know that the first mark is at 29 centimeters and the last mark is at 83 centimeters. So let's draw these 2 marks. Since all of the distances are equal, that means the middle mark is exactly halfway between the first mark and the last mark. So that means the location of the middle mark is the average of the location of the first mark and the location of the second mark. We can figure out the average by doing 29 plus 83 divided by 2, which is equal to 112 divided by 2, which is 56. So the answer to this problem is 56 centimeters. For this problem, we have to figure out how many of the 50 students took neither art nor coding. Let's draw a Venn diagram to help us solve this problem. Based on the problem, we know that 12 students took both subjects, so we can write 12 here. We also know that 25 of them took art, so that means the number of students that took only art plus the number of students who took art and coding is equal to 25. To figure out the number of students who took only art, we can do 25 minus 12 and we get 13. We also know that exactly 20 students took coding, so that means the number of students who took only coding plus the number of students who took coding and art is equal to 20. So the number of students who took only coding is equal to 20 minus 12, which is 8. We know that there are 50 students, so the number of students who took neither art nor coding is equal to 50 minus all of these students. So we would do 50 minus 13 minus 12 minus 8, and we get 17. So that means 17 students took neither art nor coding. For this problem, we have to figure out the length of each side in inches. We know that a piece of wire that is 10.5 feet long is bent to form a regular hexagon. So let's figure out the length of the wire in inches. So 10.5 times 12 is equal to 126. Since a regular hexagon has 6 sides, we can divide 126 by 6 to get the length of each side in inches. So 126 divided by 6 is equal to 21. So the answer to this problem is 21 inches. For this problem, we have to figure out the length of the track in yards if the distance between each flag is equal to 18.5 yards. We know that there are 7 flags placed on a straight racetrack. We also know that the first flag is at the start line and the last flag is at the finish line. So let's start by drawing 7 flags. We know that the distance between each of the flags is equal to 18.5. Looking at the flags, we see that there are 6 distances, so that means the length of the entire track is equal to 6 times 18.5, which is equal to 111. So the answer to this problem is 111 yards. For this problem, we have to find the cost of a large birthday cake. We know that a large birthday cake and 4 mini cakes cost $60 altogether. So that means a large cake plus 4 minis is equal to 60. We also know that a large cake costs $20 more than a mini cake, so that means a large cake is equal to a mini cake plus 20. We can replace the large cake in this equation with a mini cake plus 20. So we have 5 minis plus 20 is equal to 60. Subtracting 20 from both sides, we have that 5 mini cakes is equal to 40. Dividing both sides by 5, we have that a mini cake is equal to 8. We also know that a large cake is equal to a mini cake plus 20. So that means a large cake is equal to 8 plus 20, which is equal to 28. So the answer to this problem is $28. For this problem, we have to find the location of the middle mark. We know that a yardstick is marked in 5 places with equal distance. We also know that the first mark is at 13 inches and the last mark is at 34 inches. So let's draw the first and last mark. Now let's draw the 3 marks in between the first and last mark. From this problem, we know that all of the distances are equal. So that means 2 equal distances are equal to 2 equal distances. So this means the middle mark is exactly halfway between the first mark and the last mark. To find the average of the first mark and last mark, we can do 13 plus 34 divided by 2, which is equal to 47 divided by 2, which is 23.5. So the answer to this problem is 23.5 inches. For this problem, we have to find how many steps were on a ladder using the clues above. So let's draw a line to represent the ladder. Our first clue is that he stood on the middle step of the ladder. So he starts on this point. Our second clue is that he went up 3 steps. Our third clue is that he went down 5 steps. Our fourth clue is that he went up 7 steps. And our last clue is that he went up 6 steps. To figure out the number of steps on the ladder, we have to figure out the number of steps he climbed to reach the top of the building. We can do this by adding up the number of steps he climbed and then subtracting the number of steps he went down. So this would be 3 plus 7 plus 6 minus 5, which gives us 11. So that means this distance is 11. Based on the problem, we know that he started on the middle step. So that means there are also 11 steps below him. Now we can figure out the number of steps on the ladder. So it would be 11 plus the middle step plus 11, which is equal to 23. So the answer to this problem is 23 steps. For this problem, we have to find the greatest number of points of intersection that can occur when 2 different circles and 2 different straight lines are drawn on the same piece of paper. So let's start by drawing 2 intersecting circles. Now we can start to draw the lines. To maximize the number of intersections, we want the line to go through both circles, so it would look something like this. Now we have to draw one more line. To maximize the number of intersections, we want this line to go through both circles and this line, so it would look something like this. Now we can count the number of intersections and we get 11, so that means the answer to this problem is 11 intersections. For this problem, we have to figure out how many pages the book has altogether. We know that on the first day she read 2/5 of the total number of pages. We also know that the ratio of the number of pages read on the second day to the third day is 3 to 5. Finally, we know that she read 18 more pages on the third day than the second day. We can solve this problem by figuring out the number of pages she read on the second day and third day first. So we know that the number of pages she read on the second day can be represented by 3 units. And the number of pages she read on the third day can be represented with 5 units. We also know that she read 18 more pages on the third day than the second day, so that means these 2 units represent 18 pages. And since there are 2 units, that means each unit represents 9 pages. So the number of pages she read on the second and third day is made up of 8 units of 9 pages each. So we can do 8 times 9 to figure out the number of pages she read on the second and third day. 8 times 9 is equal to 72. Now let's figure out how many pages she read altogether. We know that the number of pages she read on the second and third day is 3/5 the total, since she read 2/5 of the total on the first day. So that means 3/5 of the total number of pages is equal to 72. To find the number of pages, we can divide both sides by 3/5. So the number of pages is equal to 72 divided by 3/5, which is 72 multiplied by 5/3, which is equal to 120. So the answer to this problem is 120 pages.